We're interested in ways to measure better how plants are growing. It's really useful to be able to do that from satellite because then you can do it in lots of places and over time.
The primary questions that we try to answer is that we try to understand how much crop grow in the US and what is their productivity and how they respond to climate variabilities.
There's lots of different ways of doing that. And so what we were looking at in this study was a new way using what's called fluorescence, which is essentially this very faint glow that plants give off as they grow. It's really hard to measure, but people have figured out recently how to measure it, and we were testing, does it really provide a good measure of plant growth or not?
The fluorescence that we measured from the satellite is a very tiny small energy that emitted from the plant. Imagine you have a leaf, you receive sunlight, and most of the energy that you receive will be used for photosynthesis. But there will be a small portion that plants or leaf don't need to use. And so they will either dissipate as heat or they will emit as fluorescence.
I think of it like crumbs falling on the ground as people are eating, and it's a very small trail. This glow that plants have seems to be very proportional to how fast they're growing. So the more they're growing, the more photosynthesis they're doing, the brighter they're fluorescing. So if there's a day when the plant is really stressed, you'll see the fluorescence really drop, right? So you're able to capture these really short-term responses to environmental changes, which helps us understand like what is it that plants are really responding to on the daily time scale. And that helps us, for example, figure out, like with crops, what do we need to worry about in terms of stresses that crops are really responding to? What should we really be focusing on in terms of the next generation of crops? What should they be able to withstand that the current crops can't withstand?
Previous satellite approach measured photosynthesis indirectly either through the plant's color or their structure. But now using fluorescence, we can directly measure photosynthesis. In the future, we can use this fluorescence technology to monitor the global food production, for example, the food production in China or in Brazil or even at your backyard.
Historically, we've been doing a decent job at understanding how big plants are. What this really lets you to look at is how fast are they doing photosynthesis. And so the difference between the two can really tell you a lot about how plants are using energy themselves. So it would be like if you're interested in somebody's weight management and all you knew was their weight, that would tell you something. But if you also knew kind of how much they were eating and how much they were exercising, you can start to untangle like what do you need to do to be able to lose weight in the case of people or gain weight in the case of crops. There's a couple satellites that people have figured out how to measure fluorescence with. I think the interesting thing is none of them were actually put up in space to measure fluorescence. They were really put up there to measure things like ozone or CO2. But by pretty sophisticated techniques, you can kind of pull out how much fluorescence is coming off of the plant.
Deriving satellite-based fluorescence only happened in the recent 3 years. So this is really new. And when I first arrived in Stanford, David and I discussed about the possibility of using this new technology, fluorescence, which is potentially could be an indicator of photosynthesis for the large-scale crop monitoring.
This is one of the first studies to really look at the space-borne fluorescence measurements and see does it track changes in agricultural productivity.
During the past year, NASA just launched another satellite called OCO2. And that satellite has a specific function that's designed to measure fluorescence.
I think one of the really cool things about fluorescence is that it really opens up a whole new set of questions that we can ask about vegetation. And oftentimes it's these new measurements that really drive kind of the science forward in the sense of opening up new possibilities.